are now recording. So let's set up for the first slide, our current slide. And let me go over, goodness gracious. That's not a current slide, okay? I don't know where it is there. All right, let me go over a couple more announcements. For this week and next, office hours get a little crazy. Of course, this week, today is normal. Office hours 10:45 to 1:15. And then I teach until whatever it is, 5:45. And probably be in the office another 15 minutes or more there. But tomorrow is a strange day, okay? I think I'm going to start on the Birmingham campus, 7:45 until 9. I have we have a departmental meeting from 9 till 10. Then I'll be back in the office on Birmingham campus from 10 till 10:30. Then at 10:30, I'll leave Birmingham to come over here so we can do the class over here. And that's when we're making up for next Tuesday's class. And then that will be 11 to 12:15, right? Okay. When? At 11 o'clock. Where? Friday. Oh, shoot. Yeah, I got to find out which campus. Where is your, are you in that humanities course? Where does it meet? Here. And what time? From 9 till 11. 9 till 11. I would think they'd almost have to have the meeting here then, wouldn't you? Sometimes they do, sometimes they have a drive over. Yeah, but they can't have it start at 11 if that finishes at 11, can they? No. Well, I don't know. So how long will that meeting go? Do you have an idea? An hour? So you want to do it 12 to 1:15? Yes, that would be better. 12 to 1:15. Okay, change from Tuesday. So what we'll do is have I'll be on Birmingham campus. I'm guessing, this is just a guess here, see, after our class on Tuesday, I got an email from my boss's secretary saying that they needed us to meet with our departments before next week. Well, yesterday was a washout, literally. Today, I didn't get anyone saying they could meet on Tuesday or Thursday, so that leaves tomorrow. And I know that some people have a 10 o'clock class, so I'm hoping that 9 o'clock will work best for most people. So that's why I'm saying on the Birmingham campus we'll have a meeting from 9 till 10. So then I'll be there from 7:45 till 9, then in my meeting 9 to 10, and then I'll be back in the office then from 10 until 11:30, and then I'll drive over here and try to be here by 12 o'clock. Okay, so if 12 o'clock fits anybody else any better than 11, hint, hint. If 12 o'clock fits any better than 11, help. If 12 o'clock, Earth to students, come in, please. Okay. If 12 o'clock works any better for you than 11 did for the makeup tomorrow, I don't think it will, but okay. Amber, work too. Okay. All right. So it doesn't. But for anyone that's listening at home, we will have the makeup class around 12 o'clock. Now, if I get held up by a train or something, then I may be a little later getting here. But don't leave, Chevette. I will get here as soon as I can. And if your meeting runs over, I'll wait until you show up here. So you wait on me, or I'll wait on you, or we'll get started right at 12. Okay. We'll go 12 to 1:15, even though that takes me 15 minutes over. I can live with that. Okay, so that'll be the makeup. Then next week is, for this class, is pretty much a disaster. Number one, I have a doctor's appointment on Tuesday. Doctor's appointment's at 11, but I have to be there for labs at 10, which means I have to leave here at 9:15. Wipes out this class completely. Thursday is Honors and Awards Day, which I have to leave to be probably 8:15 to get over there by 8:45 to be dressed and ready by 9 o'clock to proceed in at 9. And
start exactly at 9?
that's what my understanding is. Is that what you understood? That's what another student told me. But she said she didn't.
I wasn't sure if we had to be there at 9 or if it,
Okay, you being an ambassador or a recipient. Okay, you have heard from your department or whoever?
Yeah, they sent a letter that said that I had to be there at 9, so.
You had to be there at 9.
Yeah.
So you think it may start later than 9.
That's what I was thinking.
That's what it sounds like to me. I've got to ask too, and I may then meet with my pre-calculus algebra class. If it starts later than that, then if I don't have to be there till 9, I can meet with them for at least a half an hour. So I think I'll do that. So I'll find out too. So okay, that sounds more reasonable. Okay. So things may still be up in there a little bit. This class won't meet either Tuesday or Thursday, so that's why we're meeting tomorrow at 12. Okay. Now, we're on page 376, Chapter 5, Analytic Trigonometry, Section 5.4, Sum and Difference Formulas, and we had done example 1. Okay, and that's the answer we got. And yes, okay, I see what it was. We had already done example 2, and we were going to do example 3, and that's why we were starting at that strange location. Okay, now I remember. Let me get my pen set up for something dark. And the first question I have is, do you have any questions on anything we've covered so far? Let me say this too. I guess since we're making so many long announcements today. This class, of course, one of my best classes, obviously, okay? I have had one research paper turned in, and only one. Okay. Prefer not, but I will accept the last day of class. But if it's after the last day of class, you start losing points. Okay, if it's like finals. Okay. Not the last day of the term, but the last day of class. Okay. Okay. All right. Okay. All right. You mean? All right. Now, I've only got one class with fewer papers in, but that class only has 4 students in it. Okay. Well, I have another.
4 students in it, but you wouldn't teach that chemistry class that had like 6 people?
I'm not credentialed to teach chemistry. I wish I could have. I love chemistry. But no.
It's the one class I needed, and I couldn't get it.
I wish they'd let me, because I would have loved to teach that. Which one was it?
111.
Okay, that's just inorganic chemistry, right? Yeah, I would have loved teaching that. But organic, I would not have loved teaching. But
I hated chemistry in high school.
oh goodness, that was
My
one of
teacher
my
wasn't.
favorites.
I didn't know what to do. I had no idea how to do any of it.
I had to take 111 and 112, and like I had to choose between biology or chemistry because I couldn't take both because they canceled the one class I could take.
Sorry. Yeah, I wish I could have taught it. Okay, so anyway, I've only had one student turn in papers. Now, the first test, all but one student has turned in the first test. And that student's not here, so hopefully he will hear this and know. But, you know, I haven't received any of the second test yet. Okay? And I don't want those the last day of class. Okay? Because you're going to be getting, okay. So let's talk about that too. We are in 5.4, and we should finish that today and start on 5.5. Okay? 5.5 is not a long section, so I'm guessing that on Friday, tomorrow, we may finish 5.5, and for those who are here, I'll give you your third test, which means I would have loved to have had the second test in already. And so for the rest of you, now if you want the test today so that you'll have it, I don't have it run off, but if you'll just wait after class, I'll go down and run off the test.
Wait, we have another one before the final?
Yes.
Oh, yes. Yeah, we got chapter 6 coming. Yeah.
And the final covers
Okay.
everything that we.
Second,
The final.
will covers all 3 chapters. Yeah, we had 2 chapters and 2 tests in chapter 4, 1 in chapter 5, and we'll have 1 in 6. We may not cover all of 6. I don't think we'll have time for that. But we'll have a test on as much as we do cover, and then the final will cover all of those. Okay. I've given you take home so far, so what I think I'll be doing is giving you a short test for chapter 6 and a short test for the final. So it'll be probably easier than either of the full tests or the next one that we have to do, because there'll be fewer questions or no more than the sum total of those 2. That'll be very straightforward and fairly easy to do. So I'll give them to you as take homes, unless you want to come and take it. All right. So let's proceed with example 3. Find the exact value of sine. Wait, I'm sorry, I'm reading the wrong one. Example 3. Find the exact value of sine of u plus v, given that sine of u is equal to 4/5. Okay? And 0 is less than u is less than pi halves. Okay? And one more piece of information, cosine of v is equal to minus 12/13. Yeah. Okay. Where pi halves is less than v is less. Yeah, this is example 3 on page 376, section 5.4. Is less than pi. Okay. There's a lot of givens in this problem. Okay. What we're looking for is sine of u plus v. We don't know either u or v. But we do know that the sine of u is 4/5 and that u is where? Between 0 and pi half, which is the 0 to pi half.
Oh,
First quadrant, yes. Okay. Making fun of me, wasn't he? Okay, I'll remember that. Okay. Now, all right. First quadrant. And by the way, does that make sense? Is sine positive in the first quadrant? Yes, everything's positive in the first quadrant. And it says cosine v is a negative 12/13, but where is v? Between pi halves and pi, which is the second quadrant, and it's cosine negative in the second quadrant. Yes, it is. So our problem is consistent. Okay? So we want to know what the sine of u plus v is. Now, we can, where would you start this problem? there's several ways you can begin. How would you like to begin?
Well, there's like, you look at the formulas.
Okay, you mean the sum angle formula?
Yes.
What does that tell you?
Well, it says
Sine of u cosine v
plus cosine
plus cosine u sine v. Okay,
Well, you have sine u.
you have sine u, which is 4/5. What else do you have? Which is negative 12/13. You got that. Plus, but do we have cosine u? Pardon me? No. Is there any way we could get cosine u? Yes. How? Yes, you do. My recommendation, if you haven't figured out what I would recommend yet, anyone have an idea? Say again? I can't hear what you said. Draw a picture. Pictures are worth thousands of words. Okay? So, and since we're dealing with u, and we're in the first quadrant, right? That's what we know about u. We know we would be on a 5 circle, not a unit circle. Why would I say a 5 circle? What is sine in terms of x, y, and r? These are questions you should be asking yourself, okay? Self,
What was the question?
okay. What is sine u in terms of x, y, and r? Stuff you should know down pat by now. Is what? Opposite over hypotenuse. And what is the opposite side? It's the y. Okay, and what is the hypotenuse? The r. So, why did I say a 5 circle as opposed to a unit circle? Sine was y over r. R being the radius. So that's why I said a 5 circle. So I would tick off, meaning make mad. 5 here. 5 there. And I don't need the other 2, do I? Because we're in the first quadrant. So I'll draw me an arc between those 2. And the opposite is 4. So that would be here. So this would be my angle U. Right? Because the opposite, my circle is very poor. It should be bulging out a little bit more like that. The opposite is 4. The hypotenuse is 5. What does that make the adjacent? 3. Very good. 3, 4, 5 triangle. So guess what the cosine of, I'm sorry. Yeah, cosine u. That's what we're doing. What's the cosine of u? What is the cosine of u? Say again? Adjacent over hypotenuse. And what was your adjacent? If you just told me it was 3, what would your cosine be then? 3 over 5. I feel like a dentist. Okay. Now, because I don't have much room, I'm going to erase this drawing, or at least parts of it. Okay? Too much of it. Okay. And draw back some of it. Okay. extend down here a little bit. Now this one, V, where is V? Where are you, Waldo? In what? Second quadrant, between pi halves and pi. Okay? And what circle do I need here? What radius? Second? For V. 13 circle. So let's make this my 13 up here. This is my 0. Halfway in between there would be 6.5, so I'll put 6 there and 7 there. And that would put a 3 there, and a 1 and a 2 there and there, a 4 and a 5 there and there. 13, no, I'm sorry. 7 to 13. Halfway in between there is a 10. And there would be 8 and 9, and 11 and 12. Let's do the same thing here. I hope I'm about the same length. It would be 6 and 7, 3, 1 and 2, 4 and 5, 10, 8 and 9, 11 and 12. So this is my circle there. Okay? And what does cosine V represent? In terms of X, Y, and R. Cosine V is?
13 will be the radius.
Got it.
And then 12 will be cosine.
Maury's here while y'all are still hashing that out.
The adjacent is 12.
Adjacent is 12. Actually, it's actually a minus 12, which puts us in the second quadrant, which should make you feel warm and fuzzy because that's exactly where we're supposed to be. So minus 12, that'll be your adjacent side, so you must be right about there. Well, somewhere there. Okay. But in order to get sine of V, you need to know the what side? Opposite, which is, in this case, your... Say again? Okay, but you know it's the y value, same as before. Okay, somewhere here, wherever that is, 12. Okay, now, is it hard to calculate? How would you do that? Say that again. Okay. Okay, a squared plus b squared equals c squared. Do you know what c squared is? Pretty close to 169. Okay, let's try it. And a squared? 144. And your b squared would be the difference between those. And what would that be? Good. So what would b be? 5. So b would be 5. Okay, and that's a positive 5. You're in the second quadrant, and sure enough, sine is positive in the second quadrant. So that's a positive 5. So what would be your sine of V? What would be the sine of V? Say again? 5 over 13. Perfect. Okay? So, this is going to be minus 48 over 5 times 13, 65. Okay. Plus 15 over 65. And that would be what? Negative 33, you said? Okay. Negative 33 65ths. All right. They didn't ask for what the angle is, but you could conceivably come up with that. But to me, it's sort of interesting to check. You know, this is the angle V. And if you remember, your angle U was something like this. And if you add this U to that V, where would you wind up being? Especially in which quadrant? Just by looking at it. This is our U. Remember, the sign was 4 over 5. Leaving this is 3 over 5 there. So you're somewhere here greater than 45. V was over here close to 180. Right? Just had a little bit to go to get to 180. So if you add something greater than 45 to 180, where are you? Third quadrant. And what is the sign in the third quadrant? Positive or negative? Negative. Sure enough, you got the sign being a negative number. This doesn't guarantee you're right, but at least it tells you you're in the right quadrant, you're in the right ballpark. Okay? So minus 33 65ths, and that's exactly what they got. All right. There is a checkpoint. It sounds like to me that would be a pretty good idea for y'all to work on the checkpoint. Okay? All right, let's move on to example 4. Okay. Write this. The cosine of the arctangent of 1 plus the arccosine of x as an algebraic expression. Write that as an algebraic expression. How would you proceed?
Cosine U plus V.
Say again?
Cosine U plus V.
Okay, you start this way. Cosine of arctangent. Time out a little bit here. Arctangent of 1 takes so much to write, and I'm lazy. What is the arctangent of 1? It's what? Inverse tangent of 1. What is the inverse tangent of 1? Yes, you do. Say again? Okay. Say again? Okay. Are you saying should that be a negative 1? I don't think so. It's just arctangent of 1. Arctangent of 1. Okay, remember, a trig function operates on an angle and gives you a number. The inverse operates on the number and gives you an angle. So what angle, when you take the tangent of it, gives you 1? See, this expression here is equivalent to, if you want to give that a name, I'd say just don't name it x, because we already have an x in the problem. But Jasmine's here.
Pi fourths.
Say again?
Pi fourths.
Pi fourths. That sounds like an excellent choice. pi fourths. Okay. Okay. So let me, yeah, I think we're okay. Okay. So that's pi fourths. So what you were saying, the cosine of the first one, which is pi fourths, times what, you give me the cosine sum formula? Say again? Yeah, cosine of arc cosine of x. What's next? And EJ's here. Yeah, I'm having a pretty good class. Okay. Continuing the formula. Cosine of what sign? What SIGN sign? Minus. Sine of pi fourths times the sine of arc cosine of x. Okay. So we got that far done. Okay. First, let's tell me what the cosine of pi fourths is. Root 2 over 2. Now, I hope you can also tell me what the cosine of arc cosine of x is. X, you're absolutely right, because one undoes the other. So there you have an x. Minus what sine of pi fourths? Root 2 over 2 as well. Okay, my pen is really slow. Okay. Now, here's the one that takes a little more thought, perhaps. What you need is a sine of the arc cosine of x. Okay? And guess what I would suggest? You draw a picture. Okay? Now, what kind of circle you think we're going to be using here? Say again? I think a unit circle will work. Okay? Let's see if it does. So this is going to be 1, the radius of 1. Okay? Now, you tell me an equivalent. Okay, let's name this thing arc cosine of x. Let's name it some other variable, not x, obviously. And by the way, remember, the trig functions operate on angles and give you numbers. So the inverse trig functions operate on numbers to give you an angle. Okay? So if the arc cosine of x would give you some angle, give me one of your favorite angle names. A name for an angle. A variable, a sign, a symbol. Q, okay? You could use Q, so let Q equal arc cosine of x. Now what does that mean? Give me an equivalent equation for that then. One with the trig function in it, not an inverse trig function. If arc cosine of x is equal to Q, give me an equivalent equation in terms of a trig function, not an inverse trig function. Okay. Here we have some number x with some angle q. So the arc cosine of that number x is equal to that angle q. Say that same thing in another equation, but now have a trig function operating on some angle equal to some number. No, -1, that's the number. Cosine, you're right. Cosine operates on, the trig functions operate on angles or numbers? Angles. And what's your angle here? Got two choices, Q or X. Q. This is equivalent to saying cosine of Q is equal to only thing you got left. X. Very good. Okay. Boy, a dentist. Okay. Now, so this expression here, if you name something here, Q, that's as good as any. It's not X. That wouldn't work well. Okay. That's equivalent to that. Or the cosine of any angle is what? What ratio? In terms of, and this is where it gets really a little messy, but it happens to work out nicely here. In terms of opposite, adjacents, and if we're on a unit circle, the radius or hypotenuse. What is cosine? Yes, exactly, adjacent over hypotenuse. And your adjacent here, let's just call this our angle Q. That's probably too close to being pi quarters, so let me change it. Doesn't have any requirement to be that it can't be that, but let's make it here. Okay, let that be our angle Q. Okay, and then you said the adjacent side, which would be the X side, and this is where it comes in handy, because that X and that X are the same over 1. That's why I say we can get by with the unit circle, right? Because this distance here is your adjacent side, and that is your X. Okay? Okay. Now, we want the sine of this angle Q. If you know that this side is X, that hypotenuse is 1, what is the sine, by the way? Opposite over hypotenuse, which is your y over 1. What is your y there? If you know that's 1 and this is X, what is this length of that side there? Really? Yes, you do. I say it has to be less than 1. Okay, I'm not looking specifically for a number. I'm looking for an expression. What kind of triangle does this little thing make? Yeah, that's a 90 degree. X and Y are always perpendicular to each other, right? Okay, so if you know the hypotenuse on one side, the adjacent side, can you calculate the opposite side? How? Y'all told me earlier. What theorem comes to mind? Pythagorean theorem. And how does that state?
squared, C squared.
Okay, and what are those things?
Work on get B squared.
Second, we're looking for B squared, okay? We'll call this B then. Okay, we already know A and we know R, or C, right? So what would B be then? If
The root of 1 minus x.
yes, this is the square root of 1 minus what? Nah. I thought you said it was A squared plus B squared equals C squared. X squared, because it's 1 squared minus x squared is what b squared is. Take a square root and you get, and we will take that to be a positive. They didn't say we could, but we'll do that. So that's 1 minus x squared, okay? So the sign of that is opposite over hypotenuse, which is the square root of 1 minus x squared. Okay. Write that as an algebraic expression. I think we just did. Since the square root of 2 over 2 is in both of them, I'll factor that out. Square root of 2 over 2 times x minus the square root of 1 minus x squared. There is an algebraic expression that represents that cosine of a sum. Does that make sense? Okay. Any questions on that? Okay. They write it slightly differently, and why I do not know, but this is perfectly legitimate. X minus the square root of 1 minus x squared, that's your numerator, over the square root of 2. Now, why do they turn around and put a radical in the denominator? I don't know, but they do. And that's another perfectly good answer. And this just is another illustration of why I find the, what do you call it, computerized homework systems like WebAssign and stuff like that. If they were looking for this answer and you put down that answer, they say, no, you're wrong. And of course you're right. And I don't know how long it would have taken me to figure out that's the one they're looking for. Because most of the time we don't put radicals in the denominators. So that is just grounds for frustration in my point, in my viewpoint. There is a checkpoint there, especially with how many teeth I had to pull to get that one. I really think you need to work on these two. All right, let's move to example 5. Before I go too far here, no. Okay. Before you get to example 5, I thought this would be on here. Here is a drawing, it's not a picture really, of a representation of the really famous ancient Greek astronomer Hipparchus. And what makes him so noteworthy is the fact that he is credited with the invention of trigonometry. And in doing so, he also derived the formulas for your sum and difference formulas. Sine of a plus or minus b and cosine of a plus or minus b. Pretty sharp character, okay? Lived almost 200 years before Christ was born, okay? This was way, 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 way back. And he came up with this. The reason he came up for it, he was trying to determine values for distances to planets and stars and suns and things like that. So he needed to develop the math to do it. So he came up with trigonometry. So use a difference formula to prove this cofunction identity. There is what we already know to be the cofunction identity. Can we prove that using a difference formula? to hear a rousing yes.
Yes.
All right, good. How do we do that? What's your cosine of a difference? What's the cosine of a difference?
It's cosine U, cosine V.
Okay, and what's your u in this case? Pi halves times
Cosine
x
plus
plus
sine pi
sine pi halves
sine
sine x. All right. That, they say, but we don't know yet if it's true, is sine x. Well, let's see if it is. What is cosine of pi halves? Zero. All right. And 0 times cosine x would be 0. And what is sine of pi halves? 1 times sine of x is sure enough sine of x. There it is. Done. Okay. So let's erase what I did and see how they do it. They start by writing it down again. And using the formula for cosine u minus v, which is cosine pi halves cosine x plus sine pi halves sine x. But cosine of pi halves, as you mentioned, was 0, and sine of pi halves is 1, so that gives you sine x. And that's what you set out to prove. Any questions on that? Pretty simple. Okay? Now, excuse me. The sum and the different formulas can be used to rewrite expressions such as, remember you've seen this before, sine of pi halves plus n pi over 2. That would be like if you had some general solution that you wanted to do like that, or cosine pi halves plus n pi over 2, where n is an integer. And we want to rewrite that involving only sines and cosines. And the resulting formulas are called reduction formulas. Okay? And I have a feeling example 6 is going to be one of those like that. So let's see if they show it. No, they don't. All right, so let's do example 6A first here. The cosine of theta minus 3/2 pi. What would that be? Cosine theta, cosine 3/2 pi. Is that what you said? Okay. Plus sine theta, sine of 3 pi halves, 3/2 pi, whichever you want to say. Okay. What is cosine of 3/2 pi? 0. Okay, so this one's 0 plus, and what's sine of 3/2 pi? -1. So rather than plus, that becomes a minus sine theta. So cosine of theta minus 3/2 pi is the same as minus sine theta. And that's what they got. Let's see if we can do that next one. the B one, we're looking for tangent of theta plus 3 pi. Okay. Do you remember your tangent sum of a sum formula? In our case, that would be say again? Tangent theta, tangent of 3 pi over 1 minus tangent theta over, wait a minute, yeah, wait, is it over? Well, then this up here should be a plus, shouldn't it? Oh, you did. I didn't hear it. Okay. Okay. All right. Tangent theta times tangent of 3 pi. All right. I think you can probably come up with what my next question will be. What is tangent of 3 pi? 0. Okay. So what would your numerator become then? Tangent theta. Your denominator would become 1. So it's tangent theta. All right. And in reality, you really didn't need to do that too well because remember, since the period for tangent is pi, the tangent theta is equal to tangent of theta plus pi or plus 2 pi or plus 3 pi. That is tangent theta. That shouldn't have come as a big surprise. But we've shown it and proved it. They do have checkpoints here, so by all means do those. All right, I think they do have, example 7 on the slide set. Goodness gracious. Sorry, I had a bad night last night. I don't know why. I think it was a temperature change or something. So I can't quit yawning today. Find all solutions for, or of, sine of x plus pi fourths. Now, here they have sloppy representation. This should be an in bracket there, okay? Sine of x plus pi fourths. Yeah, they do have it in the book. Good for them. Plus sine of x minus pi fourths equal what? Okay? Now, they're not claiming this as an identity. They're looking for this, and they want all the solutions in the interval 0 to 2 pi. So how would you begin? Sine of x plus pi fourths plus sine of x minus pi fourths. Say again? Okay, I can't hear you. Yeah, and so what would that first one be? Right? Plus cosine x sine pi fourths. That's the first one. Okay. Plus sine x cosine pi fourths minus cosine x sine pi fourths. Okay, we've expanded those two, and supposedly that's equal to 1, or negative 1. Okay? This isn't an yuck. Where are you doing here? Okay. I was trying to get my eraser to show up. Okay. So we need to solve that equation and find the values of x which make it true. So what's one of the first things we're going to need to know? Second? Okay. Okay. So yeah, that is a good thing. This and that add to 0. Okay. So that gives us 2 times the sine of x, but what is cosine of pi fourths? Square root of 2 over 2, and we've got 2 of them, and that's supposedly equal to negative 1. This 2 can cancel or divide out that 2, and this gives you, I'm going to write the square root in front, the square root of 2 times the sine of x is equal to minus 1. Okay? And where do we go from there? Divide both sides by root 2. Okay? That gives us sine of x is equal to say that again. Only with a negative sign, right? Okay, minus root 2 over 2. All right, now the question is, what angle x, when you take the sine of it, gives you a negative root 2 over 2? And we want that x to be in the interval 0 to 2 pi. And that would have been a correct answer, just not in the interval. So where is negative pi fourths? What is a coterminal angle with negative pi fourths? Yes, 7/4 pi is exactly right. So one of these x's will be 7, if I could write, 7 pi over 4. Okay? Is there another? In the interval from 0 to 2 pi. Now, again, I find it useful either to draw a picture or draw a graph. Both of them will help, I think. Picture my 5/4 pi, because you know that the sign is negative where? Where is the sign negative? Third and fourth quadrant. 5/4 pi is in the third quadrant, and 7/4 pi is in the fourth quadrant. Make sense? 5/4 pi is 1/4 pi past pi, and 7/4 pi is 1/4 before you get the 2 pi. Yeah, those are the two. Okay. That's our answer. Let's see how they did it. Using the sum difference formulas, that's what you come up with, just like we did. And then just like we did, you note that the cosine x sine pi force, one's positive, one negative, they add to be 0. That gives you 2 sine x cosine pi force. And that's equal to negative 1, but cosine pi force is root 2 over 2. And the 2 in the numerator before the sine x and the 2 in the denominator after the sine x divide out, giving you, and then you can divide both sides by root 2. They skipped several steps there. And that gives you sine x is equal to negative 1 over root 2, which is the same as negative root 2 over 2, which is what you saw right off the top. And then you look for the two values, the only solutions in the interval from 0 to 2 pi would be 5 fourths pi and 7 fourths pi, just like you saw. Okay, that was example 7. We still have example 8 to go. Well, I think we have time to do it. Okay, so here is a verification. Sine of x minus h minus sine of x divided by h. Now, do y'all have any remembrance of what that is often called? Here we have the difference of two functions, and here we have the difference of h and 0, because this is x minus h and x minus 0. So that, and this is a quotient, a difference quotient, like we had back in Math 112. Okay, so there's a difference quotient on the left. The right-hand side is this. Cosine x times sine of h over h minus sine of x times 1 minus cosine over h. Okay? And they say where h cannot equal 0. You can't divide by 0, obviously. Okay? Either part of that. So, how do we verify that identity? Which side would you suggest we start with? Left or right? That is the more complicated looking side, and that's why I sort of resist their suggestion of doing that. Really, I think we start here because this is using the difference. So since that's what we've been working with, let's do that first. So this would be what? Sine of x plus x minus h would be sine of x cosine h plus, no it's not, huh? Minus, okay. No, I stopped. I was starting to do the next part. Minus, it's a minus there. Oh, that's a plus here. Okay, sorry about that. Yeah. So that is a plus there. Okay. Next. Cosine x sine h minus sine x. Okay. All that over h. Now, not real clear what they do next, I'm going to give you a hint. Since you have an h in the denominator, let's get all the terms with cosine h over that h all the terms with sine x, well, let's see, let's say it a different way. All the terms with sine x together, all the terms with cosine x together. Okay? So the first one here would be sine x cosine h over h plus cosine x sine h over h minus sine x over h. You buy that? It's just splitting that up into one numerator with one three-term numerator over one denominator into three single-term numerators over the same denominator, right? Okay. Now, get the two terms with sine x together, and that would be sine x times cosine h minus 1 over h, right? Buy it? Okay. Plus cosine x times sine h over h. Okay? Now, I've got exactly what they have except in reverse order. They put the cosine x sine h over h first, and the, whoa. Oh, yeah. I see what, yeah. What else they did, they flipped this around, making it negative. Okay, so that's why they did cosine x sine h over h minus, when they flip these two signs, it puts a minus sign in front, and that would be 1 minus cosine h. Well, sorry about this. Yuck. Get in a hurry and I get crossed up. Okay. Minus the sine x times, and when you reverse this order, 1 minus cosine h over h. And that gives you exactly what they have. Now, do y'all have a clue of what they use difference quotients for in calculus? Derivatives. Okay? Now, the limit of this is h approaches 0. You don't know this yet, but that's 1. The limit of this, as h approaches 0, is 0. Because it just is. Okay? So then that means the derivative of sine is cosine. That's where you get that from in calculus.
You're throwing extra stuff in there, and I'm just like,
Okay.
that's pretty.
All right. That finishes the section. We don't have time for the vocabulary. You want to do the vocabulary first thing on Friday, or would you rather do that at home and just get started in 5.5 tomorrow? I know y'all aren't going to be here, but where would you like me to start? Vocabulary 5.4 or start in 5.5? Start in 5.5. So homework exercise, you do the vocabulary 1 through 6 in 5.4. Here's your homework exercise. Either 7 or 9, any of the odds 11 through 25, any of the odds 27 to 33, any of the odds 35 to 39, any of the odds 41 to 45, 47 to 51, either 53 or 55 or both, any of the odds 57 to 63, either 65 or 67 or both, any of the odds 69 to 73, any of the odds either 75 or 77 or both, and then do 79. That's the only one like that. So do that one. And then I would take a look at the true false 81 and 83. And 85, we did one similar to that, so you might want to look at 85. I think you could do 87 or 89 or both. They're a little more difficult, so don't get hung up with it, but I think you could still do it. 93 or 91 or 93, I think you could do either one of those or both if you wanted to, but don't get hung up on it. You know, and then 95. I think you could do that fairly simply too. 97, I think you could do fairly simply. 99, up to you. I think that's pretty easy. And 101's a proof. If you want to do it, you can certainly go for it. So we'll start next time on 5-5. And that is tomorrow. You weren't here for that discussion. Oh, you were here Tuesday. You weren't here Tuesday. Okay, and you came in after we did it today. Next week is a very bad week for this class. On Tuesday, I have a doctor's appointment that covers the whole class period, so we're not having class on Tuesday. And that's my fault because I have a doctor's appointment. He only sees patients on Tuesday morning, so I couldn't help him. Okay, Thursday is Honors and Awards Day, so we can't have class then either. Now, that's the school thing, so I don't feel like we have to make up that one, but I'd like to make up the other one. And the only time that anyone could do it was tomorrow from 12 to 12:15. No, I'm sorry, 12 to 1:15. So I am doing a makeup class tomorrow, 12 to 1:15 here.
That's for Tuesday, I guess, for people that didn't come Tuesday.
That's the people who, no one will be here next Tuesday because I've got a doctor's appointment. So that's making up that class.
Okay.
So if you can be here tomorrow from 12 to 1:15, I will be making up that class. Now, if I'm not here right at 12, I may have gotten held up by a train or something. I will be here, but I'm coming from the Birmingham campus because I got a meeting in the morning over there and I've got to drive over here. So I'll try to get here before 12, but if I'm not, I'll get here soon after 12.
Okay.
And we'll be in the
Research paper due for trigonometry?
Yeah, it's due before the last day of class, or by the last day of class. Get it to me sooner if you can.
Yes.
All right, good deal. Thanks. Also, the second test.
Oh, I'm sorry, what was that?
You do have that, don't you?
Oh, the second test?
Yeah.
No, I don't.
You don't? Okay. Okay. Yeah, you turn in the first test. The second test is it had a lot of the graphic ones on it. You didn't get that?
No.
Okay. Find it for you.
When he gave it out.
Oh, a while back.
That probably wasn't huge. I don't remember giving it. And what does the second test do?
As soon as you can get it to me, because we're going to be on tomorrow. We're going to get started on 5.5, and probably Tuesday, when a week away, when we finally have class again, we should finish 5.5. And I'll give you the test, the third test that day.
Oh.
So here's your second test. The first 9 of them are graphing, and then the rest of them are fill in the blanks. Do you have graph paper, or do you need it?
Need some.
Okay. Let me see if I have any run off. I know I had some.
Right, just buy some.
Yeah, well, no, I can run you off some pretty quickly, I think. Because here's a page. So you got 9 questions. One gentleman in this.